Hello students. Our today topic is voltage control oscillator IC566. So what is a voltage control oscillator? The generation of signal is the basic requirement for a wide variety of applications. Hence a number of manufacturers fabricate a selection of integrated circuit oscillators and function generators on single chip. Two of the popular ICs are the voltage control oscillator and the phase lock loop ICs. The voltage control oscillator is an oscillator whose oscillating frequency varies in response to a control voltage VC. A common type of VCO available in IC form is Signetics NE or SE566. The pin configuration and the block diagram is shown in figure. So, referring to the timing capacitor CT. Yeah. So, a voltage control oscillator is an oscillator with an output signal whose output can be varied over a range which is controlled by the input DC voltage. It is an oscillator whose output frequency is directly related to the voltage at its input. The oscillator frequency varies from few hertz to 100 of gigahertz. By varying the input DC voltage, the output frequency is adjusted. Types of voltage control oscillator. It has two types. One is the harmonic oscillator and the other one is the relaxation oscillator. The output is a signal with a sinusoidal waveform. Examples of crystal oscillator and tank oscillators. Relaxation oscillators. The output is a signal with a sawtooth or triangular waveform and provides a wide range of operational frequencies. The output frequency depends on timing of charging and discharging of the capacitor. A practical VCO LM556. A practical VCO is the LM556. The LM556 is a the LM566 is the general purpose VCO that may be used to generate square wave and triangular waveform as a function of input voltage. The LM566 is specified for operation over 0 degree to 70 degree centigrade temperature range. The frequency of which is a linear function of controlling voltage. The frequency is also controlled by an external resistor and capacitor whose values controls the free running frequency. So this is the VCO pin diagram. So it has 8 pins from 1 to 8. So one is ground pin, second one is no connection, third one is square wave output, fourth one is triangular wave output, fifth one is modulation input, sixth one is timing resistor, seventh one is timing capacitor, and the eighth one is VCC. Okay, so pin description. So here the timing capacitor CT is linearly charged or discharged by a constant current source or sink. The amount of current can be controlled by changing the voltage applied at the modulation input, that is pin 5, or by changing the timing resistor RT external to the IC chip. The voltage at pin 6 is held at the same voltage as pin 5. Thus, if the voltage at pin 5 is increased, then the voltage at pin 6 also increases, resulting in a less voltage across RF and thereby decreasing the charging current. The voltage across a capacitor CT is applied to the inverting input terminal of the schematic trigger A2 via buffer amplifier A1. Now let us look into the working of LM566 oscillator. So the LM566 oscillator, this is the exact circuit diagram. The output voltage, the figure shows the IC or IC contains current sources to charge and discharge an external capacitor at a rate set by an external resistor, and then the modulating DC input voltage V. So the output of voltage of the skimmed trigger is set to a level of VCC and 0.5 VCC. If RA is equal to RB, then the positive feedback path, the voltage at the non-inverting input terminal swings between 0.5 VCC to 0.25 VCC. Okay, so when the voltage of a capacitor exceeds 0.5 VCC during charging, the output of skimmed trigger goes low. The capacitor now discharges, and when it is at 0.25 VCC, then the skimmed trigger goes high. Since the source and the sink currents are equal, the capacitor charges and discharges for the same amount of time. This gives a triangular voltage waveform across CT, which is also available at pin 4. The square waveform output of skimmed trigger is inverted by inverter A3 and is available at pin 3. So a 0.001 mu farad capacitor is connected to pin 5 and pin 6. A skimmed trigger circuit is used to switch the current sources between the charging and discharging of the capacitor, and the triangular voltage produced across the capacitor and square wave from the skimmed trigger are provided as outputs through buffer amplifier. Both the output waveforms are buffered so that the output impedance of each is F2. The typical magnitude of the triangular wave and the square wave is 2.4 volt peak to peak and 5.5 volt peak to peak. So it has the features. The maximum operating voltage is 10 volt to 24 volt. High temperature stability. Operating temperature is 0 degree centigrade to 70 degree centigrade. The frequency can be controlled using current, voltage resistor or capacitor. Power dissipation is 300 millivolt. Excellent power supply rejection. So it has an applications of function generator, tone generator, FM modulation, frequency shift keying, and clock generator. Now let us look into the what is generally an VCO and its recap. A VCO is an oscillator with an output signal whose output can be varied over a range which is controlled by the input DC voltage. It is an oscillator whose output frequency is directly related to the voltage at its input. Next one is it has two types. One is the harmonic oscillator and the other one is the relaxation oscillator. So once again we may see what is its operation and what actually this performs. So the timing capacitor CT is linearly charged or discharged by a current source or sink. The amount of current that can be controlled by changing the voltage VC applied to the modulation input or by changing the resistor RT external to the chip. The voltage at pin 6 is held the same as the voltage at pin 5. Thus, if the voltage at pin 5 is increased, then the voltage at pin 6 is also increases, resulting in less voltage across RT and thereby decreasing the charging current. The voltage across the capacitor CT is applied to the inverting input terminal of the skimmed trigger A2 via buffer amplifier. Hence, this amplifiers as 8 pin and a program and the operation of it which we have seen. So it works in such a way that the capacitor is charged between 2.4 volt peak to peak and 5.4 volt peak to peak. Next one, the important features are the operating voltage is between 10 volt to 24 volt, temperature is between 0 to 70 degrees centigrade, and power dissipation is 300 millivolt. So it performs the function of function generator, tone generator, FM modulation, frequency shift keying, and clock generator. So hence the overall purpose of the voltage control oscillator is an oscillator whose oscillating frequency varies in response to a control voltage VC. Thank you.